Today, I will be presenting an alternative strategy for the current consumable replenishment process as it pertains to compressed gas covered by extended service plans sold to our customers for their dissolved gas analysis monitors. I will provide a company and departmental overview, including a current state look at our consumable gas processes. I will map out the current state process to help identify addressable areas for improvement. We will go over the outcome of the job mapping, as well as the areas identified as having opportunity for improvement. I will walk you through the possible outcomes ranked against one another to help determine the best possible course of action using a PSU matrix. We will go over the benefits of moving away from the standard linear model of buy, make, sell, dispose, and how that can benefit the company using a more circular economic model. I will conclude with detail on the potential annualized savings and additional value-added benefits that can be achieved through implementation of a new replenishment process. We'll start with a little bit of background on the company. Qualitrol is an original equipment manufacturer operating in the utility industry, building parts that provide transformer monitoring services for the energy grid. They were established in 1945 in upstate New York in a town called Fairport. They have expanded their operations to become a global manufacturing, sales, and support organization, acquiring multiple companies over the last 6 decades. In 2014, Qualitrol acquired a company called Serveron, which is located in Beaverton, Oregon. Serveron builds dissolved gas analysis monitors, also known as DGA monitors. The Serveron dissolved gas analysis monitor uses gas chromatography, which requires a carrier gas to be used, and the carrier gas that is used is helium. The Serveron DGA monitor is a high-end dissolved gas analysis monitor that uses gas chromatography to detect up to 8 different gases that could be within the transformer oil of a transformer. Helium is used as an inert carrier gas to move the oil from the transformer into the gas chromatography unit, which is then broken down and analyzed by proprietary means to report out the different levels of each of the dissolved gases within the oil. Different levels of dissolved gases are indicative of how well a transformer is performing, or if there are any safety concerns with the transformer, or even quality concerns. Is your transformer performing well? Is it about to blow up? Is it providing the optimization for transforming the electricity to storage containers? Currently, the steel helium cylinders that are used for the gas chromatography units last 3 to 5 years. They contain around 8,000, almost 9,000 liters of helium, but at a standard sampling rate, that helium will last in between 3 and 5 years. The steel cylinders are actually roughly 49% of the cost of the helium purchase. The rest of the cost is made up of the helium itself. Serveron sells extended service plans that range from 3 to 10 years, so that could cover either 2 or 3 helium cylinder replacements. There is an additional compressed gas that is used to calibrate the monitor. It's called calibration gas, which is a proprietary 8-gas mixture. It also has a 3 to 5 year volume. Those cylinders are aluminum disposable cylinders known as 2AL cylinders. And the extended service plans also range from 3 to 10 years for those as well. I work for Qualitrol as the supply chain supervisor. The departments that report directly to me are purchasing, shipping, and receiving. And as you can probably surmise, building dissolved gas analysis monitors and then providing service to maintain those dissolved gas analysis monitors comes with some pretty unique challenges around the world. And replenishment of helium, calibration gas, fittings, valves, and regulators that go with those. We currently have global stocking locations of calibration gas around some of the areas where we have also helium supply or helium stocking locations. Currently those locations are Dammam, Saudi Arabia, Sohar, Oman, Doha, Qatar, Mumbai, India, Dongguan, China, and Sao Paulo, Brazil. As noted on this map by the red bursts. The green dots are global manufacturing locations for Qualitrol. We have a location in Beaverton, Oregon, Toronto, Canada, Fairport, New York, where we're headquartered, and Belfast, Northern Ireland. Each of the different locations build different transformer monitoring equipment. Servron is the only one that deals with dangerous goods of the 4 locations. The Servron units that are located around the globe are areas where we source material. So we have parts from China, from Malaysia, from Singapore, from Thailand, from Japan, from Canada, Mexico, and the U.S., all within our unit. So as you can see by this map, Qualitrol is both a global supply company pulling our supply from different areas of the world while also supplying from different areas of the world. We also have a global market for sales throughout the organization. We sell into almost every continent aside from Antarctica. Units, services, and supply. And we also provide condition-based monitoring for some combined packages for specific customers. So one of the processes that I'd like to take a look at that I've identified as having the possibility for improvements is our current state process for servicing extended service plans for one of our largest domestic utilities that we service. It is a customer in Florida who purchases, installs, and commissions around 150 to 175 units per year. They purchase extended service plans for every single one of the units that they purchase, and we have been working with them for roughly the last 5 years. So it has currently been a series of replenishments over the last couple of years, and we need to establish a better process for doing that. Helium and calibration gas is currently provided as an aspect of the service plan. What happens is there is some ambiguity around who owns the steel cylinders provided. We currently purchase the cylinder outright from our gas supplier. Standard practice in the industrial gas supply industry is to rent and refill cylinders. This point causes confusion as to who is responsible or obligated to return/refill or dispose of the cylinder once depleted. Since we're buying these outright, we have nothing set up with our gas supplier as far as rental or refill at this current time. Empty cylinders are disposed of through a variety of means, including landfill-bound waste streams and boneyard storage. Boneyard referring to industrial storage areas utilized by utilities and industrial organizations for items of little to no value, also having no warehousing requirements. There could be delays in supply, causing gaps in the monitor's ability to sample and analyze gases if there are transit or coordination delays for the replenishment of the supply. We'll now go through a job mapping exercise to show you the steps of the current process as they happen today. First, the customer calls service department for a replacement cylinder. This could be triggered by either the monitor's automatic signal being detecting that the helium is low, or by a field service engineer noticing that the helium is low while they are on site doing other maintenance work. Customer service then enters the order for replacement. The buyer then places a purchase order with the gas supplier, which is located in Plumsteadville, Pennsylvania, on the east coast of the United States. The purchase order then travels to the supplier, who ships the cylinder to the transformer site. There could be a delay from when the purchase order is placed and when the supply is filled due to the timing of the West Coast, East Coast transaction there. Depending on the time of day that the purchase order is placed, the supplier may not get that till the next day. Then there's transit time involved, shipping the helium cylinder from Plumsteadville, Pennsylvania, all the way to, in this case, Florida. Coordination needs to happen for the field service engineer to meet the helium cylinder on site when it arrives in order to swap the cylinder out at the transformer site. The next step is that the empty cylinder is disposed of through whatever mean is available at the time, or the means that is available to them at the transformer site. And then the transformer is back up and being analyzed by our transformer monitor. The outcome statements from the job mapping summarized were there's a need to minimize the number of order transactions and manual intervention there. to increase the replenishment speed or to decrease the possibility of delays, to minimize the transit time and cost shipping single cylinders from Plumsteadville, Pennsylvania to Florida, reduce the handling of the material by both the customer and possibly the field service engineer, and the waste generated by that handling and the waste generated by single cylinders, and to reduce the material cost of the extended service plan. The main business opportunities from the outcomes would be to reduce the extended service plan costs and to reduce the frequency of shipments to site, which would reduce transportation and logistics costs for Qualitrol. The community impact that would be realized would be both for the community and the customer themselves. So to provide an alternative to landfill-bound waste and hassle of dealing with those cylinders, and to reduce the number of transactions or trips to the site, and to reduce the handling and possibility of injury. These cylinders are 140 pounds, and sometimes they need to be moved around or stored in a boneyard that then they need to be moved around again. So all of those reductions of movement and transactions would be beneficial for the customer. After brainstorming to determine what outcomes could be happening during the current state, as well as the possible outcomes of the future state that we could implement to achieve the identified improvements, I came up with 4 possible scenarios listed here: landfill-bound waste stream, recycling, return for rebate, or refill, and rank them as better using a plus sign, worse using a negative sign, or neutral as a 0 to the current benchmark process, which would be landfill-bound waste stream. What was determined was that there were three options that could be acted upon to reduce the waste, but only one process to refill and reuse the cylinders would be of maximum benefit to the process with a +5 rating. So refilling the cylinders would both minimize ordering and transactions, increase the replenishment speed, minimize the transit time to site, minimize the transit costs, and reduce waste. There would still be the same amount of handling of the 140-pound cylinders, but there wouldn't be the possibility of repeat handling due to long-term storage or not knowing what to do with them. Recycling provided a waste reduction element, but it did little to reduce additional costs that would be absorbed by either Qualitrol or the customer with transit time for replenishments and handling. The current process follows the typical consumption model in that a good or service is purchased or created, sold, consumed, then discarded, following a linear model with no opportunity for recovery or reuse of materials or byproducts along the way. As you can see here, the replacement need is identified, the sales order is purchased, the demand is generated, and the purchase order is sent to the gas supplier. Gas is shipped. Field service engineer, also known as an FSE, is scheduled. The helium cylinder is replaced. The helium cylinder is disposed. The new process would follow a more circular economic model as you follow the steel helium cylinders through the process. A replenishment need is identified by either the customer through the monitor automated signal or from a field service engineer on site performing maintenance or service. The FSC has pre-filled cylinders on his truck to use for an immediate swap out of the gas. The FSC can then remove the empty cylinder from the site and return to the local gas depot upon his next replenishment run. Once enough empty cylinders are collected by the local depot, they will ship the cylinders back to the fill plant in Plumsteadville, where they will be filled and returned in a bulk shipment, so 10 at a time as opposed to 1 at a time. And reusing the cylinders will reduce the price of the helium replenishment process by roughly 49% of the purchase price. And the FSE will replenish their helium supply after every 10th transformer site that needs helium to be replaced. Each replenishment process triggers a new iteration of the circular replenishment process. So this is a continuous flow of circular life cycles for the helium cylinders. So the value added by the ideal state has a high business impact of reducing costs. So the helium material cost to service the monitor reduced by $315 or 49% per cycle. T&L costs reduced by shipping in batches to and from the depot. So the current state, it's about $205 per cylinder to ship a cylinder from Plumsteadville to Florida. The batching process, we would reduce that down to $58.50 per cylinder. And it would reduce the amount of internal transactions that would need to be done by Qualitrol. The customer impact would be adding value, so removing the cylinders from the site site and establishing a responsible party for doing that activity. The fulfillment time would be reduced and the service level would be increased. We'd be seen as a company that provided a high level of service for maintenance and refilling up during our extended service plans for the replenishment process. So the annualized savings shown here would be the current state cost of 2018. We shipped 175 cylinders under ESPs to a single customer in Florida, where we already employ 3 static field service engineers in Pensacola, Orlando, and Fort Lauderdale to service the monitors in various regions of Florida and the Gulf. All 3 areas are currently staffed by the full-time FSE, and they're used to install and commission monitors and to perform maintenance throughout Florida and the growing Gulf region. So they're already there doing work. The 175 cylinders that we shipped under the ESP program in 2018 had a material cost of $101,325. The T&L cost for the 175 shipments that were made was roughly $35,875. So the total helium cost was around $137,000. Annualized savings by implementing a continuous circular helium refill process would be that the 175 estimated units needed per year going forward would be that the material cost or refilled units would be $46,000. Transportation and logistics costs to transport 10 per skid as opposed to the 1 per skid would be $10,238. And the total helium cost to service per year would be reduced down to $56,438 for the 175 units. And the savings would be around $80,000 per year, or 59% of the total cost in previous years. Now, these figures are using a static model. We know that our customer is still buying monitors, and we still have the original monitors that are in use. So as they buy monitors year over year, we will see an increase of units needed under the extended service plan. So we could either see higher cost by sticking with the single cylinder replenishment program, or we could see lower costs by going with the replenishment process as detailed out here. The program also comes with additional value-added benefits. So the keys there are that it's removing that ambiguity of the responsibility for the depleted helium assets. So currently we're seen as someone who just leaves their helium cylinders there and doesn't have a process to return or refill the cylinders. It'll reduce the number of transactions and coordination activities for Qualitrol and the customer. So it'll definitely reduce lead time in that regard. It removes the possibility of landfill-bound waste, so that would be about 12.25 tons per year that we'd be keeping out of the landfill if those cylinders are thrown away. And it reduces the number of shipments by about 139 shipments on average, so that's about 168,000 miles, or 58 trips back and forth from Portland to New York City. And the additional benefit is that it delights the customer by providing a high level of service, attention, and care for their assets. If successful in Florida, expanding the program would be easy to implement in also the Northeast region, where we have full-time dedicated field service engineers that are installing and commissioning for utilities there as well. The global depots could be set up in various areas of the world that contain the helium fill plants, as the need for routine and repeat extended service plans are sold into those areas as well. So this doesn't have to be just a U.S. region specific. This could also be a global program as we move forward. I want to thank you for your time and consideration of this new program. Thank you and have a great day.